section 5.7 is on radical exponents. So in other words, exponents that are fractions or negative fractions. Okay, and so there's a particular formula here that you need to get used to. If I have a fraction exponent, the number that is on the bottom of that fraction is the same thing as the index of my root. So b to the 1 over n power is the same thing as the nth root of b. If I have a b to the m over n power, the m is my power on the b, and my root is the bottom of my fraction. So, for instance, let's say you have 81 to the negative 1/4 power. So if you think about this, there's two methods. One method would be to go ahead and take this and go, oh, that's the 4th root of 81, but it's going to be on the bottom because I've got that negative. So I could turn around and I could go, well, that can be written as the 4th root of 3 to the 4th power. So the 4th root of 3 to the 4th power is just 3. So that's 1/3. The second method is you look at it and you go 81, you keep it as powers. You don't ever put it underneath of the root. You go 3 to the 4th power is 81, and I want that to the negative 1/4 power. A power raised to the power, you multiply, so that's going to be 3 to the negative 4 over 4 power, or 3 to the negative 1st power, which is the same thing as 1 over 3. Either of those methods will work. Okay, let's do another one. I have 32 to the 3/5 power. The first method is to go ahead and change it to radicals, so I could have the 5th root of 32 to the 3rd power. Well, I've got to figure out the 5th root is 2 to the 5th power, I believe. Let me double check that. It is, so I can rewrite this as the 5th root of 2 to the 5th power raised to the 3rd power, or the 5th root of 2 to the 15th power. 5 times 3 is 15. So the answer here would be 2 to the 3rd power, or 8. Method 2, you're going to keep it as powers and exponents. And so 32 is going to convert to 2 to the 5th power, raised to the 3 over 5 power. If I multiply those, because it's a power raised to a power, I have 2 to the 15 5th power, or 2 to the 3rd power, which is equal to 8. Okay, so either method works. It really just depends on which method you find the easiest. This one, I'm going to go 1 over 2, and this is going to be raised to the 3rd power here. And I have a negative 1/3. If you remember right, to get rid of the negative with a fraction, you can just flip it. So I have 2 to the 3rd power over 1 raised to the positive 1/3 power. So a power raised to a power, I'm going to multiply. So 3 times 1/3 will give me 3 over 3. So that's going to give me just 2 to the 1st power, or 2. Okay, that's probably the easiest way to do it. If you feel better converting it to radicals with square roots, and in this case cube roots, you can do it that way. Let's do a few more. I'm going to keep these as powers. So I'm going to change 36 into 6 squared, raised to the 3 over 2 power. A power times a power, if you will, a power raised to a power. You're going to multiply. So that's going to give me 6 to the 6 over 2 power, or 6 to the 3rd power. You can leave it like that, or you could actually do out what 6 to the 3rd power is. 27, I can write as 3 to the 3rd power, raised to the 4/3 power. Power raised to a power, I'm going to multiply, so that's going to give me 3 to the 4th power. Okay, which would be 3 times 3 times 3 times 3, or 81. Okay, you can always do those on your calculator. All right, simplifying expressions. Now on these, you know that if you have a base number that's the same, you just add the exponents. They have a common denominator, so I could rewrite this as x to the 7/3 power. Now, if you need to, you can convert those, because that can be reduced down. So you can do it one of two ways. You can either look at that as x to the 2, let's see, it goes in there, 2 1/3 times. Okay, if I go and make a mixed numeral out of that, which is equal to x squared on the 3rd root of x. So that's one way to do that. The other way to do it is to go ahead and convert it. I'm looking for the cube root of x to the 7th. 3 times 2 comes close to 7 without going over it, so I have an x squared on the outside, and I have a cube root of x to the 1st power underneath, which if you look at it, that's the exact same thing you have. Okay? Now these, if we were trying to do it the other way, it wouldn't work. So if I had a square root of x times a 4th root of x raised to the 3rd power times a 5th root of x raised to the 1st, I could look at it and go, you know, I can't do anything with that, because this is a square root, a 4th root, a 5th root. I can't combine them. But because they're in fraction exponent form, I can do something with them. I need a common denominator. The common denominator of those would be 20. So I can change this to 10/20 times, that would be 15/20, and this one would be 4/20. Now, if you look at it, they now have a common denominator. I add their top numbers, and that's going to give me a 29/20, and it's x to the 29/20th power. So if I converted that, it would be the 20th root of x to the 29th power, which is equal to 20 times 1 gives me an x on the outside, and this is the 20th root of x to the 9th power, because I can come close to 29 by 20 times 1, but then I would have 9 of those left over. Or if I came up here, that would be 1 and 9/20, so there's the 1, and the 9/20 is right there. So it can be written either way. Okay, same thing with this one. This is a cube root, this is a square root, and this is a 6 root, which you normally can't combine. So, but if I have them as a fraction exponent, I can come up with a common denominator, which would be 6. So this one is 4 and 2/6 times A. This would be 3/6 here, and the B would be 5/6. So then I just add the top values. That's going to give me a 10/6. So I have, well, actually they don't have a common denominator. Okay, I can take the 6th root. I can't combine them. So I can take the 6th root of 4 squared, A to the 3rd, and B to the 5th. And that's all I can do. Because this one has a common denominator, this one doesn't. But at least I have them with the same index. You're going to simplify some of these by converting it from fraction form to exponent form. So at first it looks like I can't do anything with this, because this is a 10 and this is an 8. But if I change it, I can change this to 2 to the, let's see, to the fifth, I think it was to the fifth, right? Yeah. So this is 2 to the fifth power raised to the 1/10th power, because it's the 10th root of it. This would be 2 to the second power raised to the 1/8th power. So the first thing I want to do is I want to multiply here. So then I have 5 times 1/10. So I have 2 to the 1/2 power over 2, and I can reduce that to the 1/4 power. Well, I can make these two fractions have the same bottom so that I can subtract those, which is what I do with division. So this becomes 2/4. So 2/4 minus 1/4 is a 1/4. So I have 2 to the 1/4 power, or another way of writing that is the 4th root of 2. It means the exact same thing. This one, again, I would write it with exponents. So I have 5 squared times n to the 4th power. And the whole thing is raised to the 1/6 power. So I have a power raised to a power. So I have 5 to the 2/6 power and n to the 4/6 power. I can reduce those. So I have 5 to the 1/3 and n to the 2/3. If I want to write them in a radical form, it's the cube root of 5 times n squared. All right. Now, with these, many times you will have a denominator that is going to have to be rationalized. So I've got a to the 1/2, and one way to do it is to go ahead and convert them to radicals if you're more comfortable with that, and then you can see how you have to change it. So you'd have to multiply this one by its conjugate. So you would multiply this a plus 1 and the square root of a plus 1, okay, because that's the conjugate of that, which is going to give me on the top, I've got to do FOIL, so it's going to give me the square root of a squared. Outside is going to give me the square root of a. Inside is going to give me the square root of a. And last is going to give me 1. On the bottom, I would just do first and last, so square root of a squared minus 1, which is over here, I'm going to have an a plus a 2 on the square root of a, because those get combined together, plus 1. And on the bottom, I'm going to have an a minus 1. So you can see that the square root is gone off the bottom. The second method is you leave them with fraction exponents. So I have a to the 1/2 power plus 1 and a to the 1/2 power minus 1. I multiply it by the conjugate of the bottom, so a to the 1/2 plus 1. So on the top I have a to the 1/2 plus 1. On the top I have to FOIL, so I have this times this, which is an a to the 2/2 power, because remember I have to add the exponents, plus a to the 1/2 plus a to the 1/2 plus 1 over a to the 2/2 power minus 1. So I can change this. This is equal to 1. These two are the same, so I combine their coefficients. And then this can be reduced down to a minus 1. So you can see you got the exact same thing, but one's written with exponents and one's written with roots. All right, let's do a couple more here. Now this is multiplication. So when I multiply, see those base numbers are not the same, but I can get them underneath the same root. So on the top, I'm going to have x cubed y, and on the bottom, if I get a common denominator for them, let's see if it'll focus in on that. Okay, the common denominator is going to be 6, so this is going to be y to the 3/6 power times x to the 2/6 power. So I can look at this as x cubed y over the 6th root of y cubed x squared. Okay, now I would have to get rid of these, and to be able to get rid of them, I'm going to need a y to the 6th and an x to the 6th. So I would have to multiply this by the 6th root of y to the 3rd and x to the 4th, because that's what's going to give me the y to the 6th and the x to the 6th. So on the bottom, I've got the same thing here. Because remember, when you're multiplying, you add the exponents. So up here, I've got x to the 3rd y on the 6th root of y to the 3rd, x to the 4th, over the 6th root of y to the 6th, x to the 6th, which again, the bottom's I'm gonna lose my radical on the bottom. And it's going to give me y and an x. Now, these two can be reduced down. The x over the x goes away, and the x cubed and the x becomes x squared. So your final answer on this is x squared on the 6th root of y cubed x to the 4th. On this one, I think I probably would just leave it in this form, and I'd multiply this by the conjugate. So I'd have a to the 1/2 minus b to the 1/2, and a to the 1/2 minus b to the 1/2. Hopefully you can read all this. Okay, so on the top, I'm going to have an a times a to the 1/2 power minus a times b to the 1/2 power. Okay, or you can leave it with the a on the outside. Often it's done that. And on the bottom, I do first and last. So that's going to be an a to the 2/2 power minus a b to the 2/2 power. So if you will, it might be easier just to do it like this. This is going to be like the square root of a minus the square root of b on the top, if I convert that and change that. And on the bottom, I'm going to have a minus b. Okay. All right, your homework on this is page 300 through 301, 24 through 54 even.